So, welcome, Brighton. Thank you so much for coming down here to explore this. We have, as you've seen, some unbelievable speakers here today, and they're going to talk a lot about a lot of the modern thinking around AI, and really go, as Danny says, in depth about that. So, my role here really is teeing them up and talking about how did we get here? How did we get here? How do we get here? So AI has already created as many images as photographers have taken in 150 years. It's kind of incredible headline from last year. And this isn't just photography. This is now happening for every different type of creative work. You've got tools that can do text to video, text to website, text to design, sort of, design prototype, text to huge bodies of new text. So we can all kind of sense we've hit this inflection point, both in the sophistication of these tools and also in the adoption of them. And kind of with that, there's kind of this problem where I think we're all feeling relatively kind of overwhelmed with the number of technologies over there, technologies available, sorry. And we're feeling unsure sometimes, I certainly do as a designer, of when to apply these different technologies to different situations. So that's the topic of my talk today. It's all the things AI can do. We're not going to go in depth into how these things work, but rather look at what they can actually do for users and when you can start applying these different technologies. As Danny mentions, so I'm a designer, I'm an engineer, but I'm also the founder of this tech startup. And for us, it really is such an important decision that we're thinking about every day, which is when do we put these different technologies into our products? And so that's something I want to talk about today. What we're going to get out of this talk is we're going to cover, at a very high level, the core ideas over the last 70 years. And so you'll have an understanding of kind of what they do in a bit of a simplified way, but also a useful way that you can think about. And then, importantly, which user needs you can start applying these to. So we're starting in the 1950s with young British polymath Alan Turing creating this seminal paper, Computing Machinery and Intelligence. And in this, he posed this profound question. If humans can use available data and reason to solve problems, why can't machines? So the available technology at the time is symbolic logic. We have statistics. We have rules. So what are these? So symbolic logic, it's way too low level for us as UX designers, but just very briefly, this is the logic of how electronics handles signals. Inside your iPhone, you've got 16 billion transistors, and they're making decisions all the time. That's where symbolic logic comes in. Statistics, the nerdy maths that you can use to predict the weather, you can do this on paper. Computers could help with that at this point. And rules engines and rules are, rather than the other two, which are sort of used behind the scenes, rules engines are something we can start to use as US practitioners today. It's still an amazing technology, and there's a lot of situations where you're going to want to use these. So I think it's worth unpacking and exploring. So firstly, briefly, what are rules-based reasoning? And well, a good way of visualizing this is decision trees. So very simply, your computer comes to a decision, uses the available information to decide, is it going to do option A, is it going to do option B, other options, maybe it goes down a branch, and there's further decisions before it comes to a conclusion. And when are you going to want to start using these? So a couple of questions. Firstly, do you have human set rules? So if you've got traffic lights, you don't want those to be reinventing the wheel about how they're going to decide. So there you want very clear rules that we set and the computer follows. Again, human-defined outcomes. You don't want the traffic lights coming off their own version of it, thinking that red and green together is going to somehow be more efficient. And again, with logic and rules, we can make this explainable. Some of the technologies we're going to come to are kind of black boxes where we don't know how you've got to the conclusion. And if you ever have a situation where ethics is involved, being able to explain how you got there is incredibly important. So I'm going to dive right in with a situation that I had myself a few years ago, which was a huge ethical situation. We were employing thousands of people up and down the country at my last startup. This connected temporary staff to the available shifts in their city. And we had this kind of obligation, because we're paying people's wages, to make good decisions here and make fair decisions here. So how do you allocate the available shifts to many people who are deserving of them? So we asked ourselves, what data really matters? Have they worked there before? We don't want to have to retrain people coming to the venue and where the toilets are. Secondly, did the last shift just go well? We had a two-way rating system, so the employees were looked after and also the employers could be rated as well. What we didn't include in there was things like location data, which can start to introduce bias. So we had a real control over what we thought was relevant. And then what are the outcomes here? Are they matched the shift? Again, very black and white. So because these are human-defined, actually it's the perfect criteria for a decision tree. So here's what we came up with. Basically, for every shift that's posted on the app, has the person worked there before? If yes, check, did they have a good two-way rating from that? Was it a good relationship? If yes, those people are first priority. If no, second priority. If they haven't worked there before, those are the third priority, and you're going to need to train them when they turn up to the venue. Really simple, scaled to thousands of shifts a week, and became a really fair system that we could explain to show how we're going to run the company. So, can machines think? I'm not sure if we'd call this thinking at this stage, but they are making decisions for us, and it's great when you have human-set rules, human-set outcomes. You want to reduce bias, you can explain the logic, and also this is cheap, which is something you're not going to get out of the modern APIs that we're going to be calling. So let's move forward now to the 1960s and ask, can machines talk? This is when we start to explore natural language. So on the right, Joseph Weizenbaum created one of the first interactive programs where you could conduct a dialogue in English called Eliza. Let's do a little demo of this. Okay, so this version of Eliza was trained to be your therapist. Some dubious ethical issues there. Can I ask for a volunteer from the audience? Sorry, it's a bit cheesy, and I know it's first thing in the morning. Can anyone volunteer some kind of problem that not they, but somebody might come to a therapist about, potentially? Any options at all?
Public speaking.
Public speaking. I'll definitely give that. Could be helpful. Okay, so it's just spat that right back at me. Did you come to me because you're anxious about public speaking? There might be some kind of pseudo commentary on psychology here. Shall we put in something else? Any other questions? Sorry?
Phobia.
Phobia, okay. Okay, so complete gibberish really coming back. It's not actually understood what's going on here. It's actually just recognizing little patterns in the string I'm putting in and giving pre-baked answers straight back to me. So part of what Joseph Weizenbaum was trying to do here was actually show how superficial these tools were. And this really weird thing happens where people interacting with this already started to form connections with it. And so this was then coined the Eliza effect. And I've seen this in my own life. So this is my dad. He is a very smart guy, trained as a lawyer. I bought him an Alexa for Christmas 2 years ago. And his first interaction with it was asking, Alexa, if it's okay, could you play Rachmaninoff's Third Symphony, please? So already he'd kind of anthropomorphized it and seen it as a person. So as UX designers, we need to be conscious of this and be asking ourselves, for this user situation, as we start to think about bringing in natural language, is connection important and is it safe? There are some situations where your tool won't be trained to give safe responses, and we want to be thoughtful about whether having a connection there is really suitable. In other situations, having that connection could actually be absolutely invaluable. Other considerations as UX designers thinking about natural language. So how do users naturally interact with this particular problem space? So forget the UI, just start to think about how people are solving this. Some situations, people just want to see the buttons, press something, and get some kind of immediate response. I'd think of this as do they need a vending machine? Sometimes that's all you need. In other situations, you're going to have a much more nuanced input from users where they're going to want to sort of expound upon what they're thinking, and then they're going to need a complex, nuanced answer. So the person really needs a therapist. And it's for you to decide what is actually the appropriate course of action. But one of the great examples of this that I've absolutely loved in recent years is the reinvention of the date picker. So we've all used the traditional wall of buttons style date picker. I know from my own experience these days, trying to find my date of birth is a humbling experience with a lot of scrolling involved. Some tools now, and admittedly, Google was doing this a while ago, but didn't really make best use of it, being Google. But a lot of tools now are reinventing the date picker and using natural language, where you can just put in how you would normally think about dates. Oh, I want to do this thing in 2 hours, tomorrow at 5 p.m., or 22nd November, X date in the past, and it immediately gives you the answer. So you can reevaluate how users are engaging. And the final thing on language I'll just say is, are users publishing text? Do you have massive amounts of text? Picture, for example, you had peer-to-peer support for some kind of health app, and people are really encouraging each other, and they're looking after each other in this app. Everyone's doing a good job. And so you get one person who comes along, they're really inspired by the keto diet, and their new mission is to convert every single person on their app to the keto diet. If you're running that app, that could be a very expensive problem to solve at scale. And this is where AI can actually help manage that volume of data. There's a whole bunch of different things that you can do to solve misinformation, safety, enriching the data, just making it better quality. There's a lot you can think about doing, but it sort of stems from this question, are users publishing text? So to wrap up on can machines talk, they've got empathy, they've got natural input, they've got natural output, they've got managing user-generated content. So we're going to start speeding up from here. In the 70s, we took all this technology out of the lab and started bringing it into factories and into the world of work. And we're not going to cover any new technologies. There wasn't a huge amount of progress. There's two really important ideas that you can bring to your UX and design work. So the first is, it's quite a boring idea, but I'm just going to cover it anyway, automation. People started mapping out the journeys in these factories that humans were doing, looking at the steps. We'd all call this a user journey today. And then they can ask themselves which steps would be handled at that time by computers. And you can do the same, asking which steps can now be handled by AI. And I find if you haven't done this for your technology or your app in a year's time, AI has moved so quickly, it might well be worth just having a revisit of this. But I'll move quickly on. Here we have one of the world's first robots. This is Warbot 2 from the 70s. This was trained to read sheet music from a camera, which you'll see on its head in a second, and then play the piano. And Warbot 2 could do a whole bunch of things besides playing the piano. What do we imagine? There was this kind of like inspiration as these machines started being able to do more things, that we'd actually get these robot butlers to be able to assist us. 1977, C-3PO walking around in Star Wars, this kind of generalized solution that can solve many problems at once. So what we actually got was very specialized machinery. It didn't work. But now, thanks to the new advances in AI, we've suddenly got this huge generation of companies that are reevaluating robot butlers. And what's more important for this, for your practice, is actually we're starting to come back to generalized solutions, where you have one tool that can do many things. You know, ChatGPT can write code, it can write you an essay, it can write you a poem. And so ask yourself, can we solve multiple problems with one interface and hide the complexity? I think it's very traditional for us to build apps with multiple screens and functions, and we've not stopped to step back sometimes and ask, could one experience actually solve these different problems? And I recognize this also brings in questions of discoverability and training users, but it does make things simpler. The other idea, and this is one that I think is an ethical minefield, is where can human roles be supported? Can we remove the tedious bits? Now, the engineer in me knows that actually AI is quite limited right now. I'm not 100% worried about the AI overlords taking over just yet, but I do think there's ethical considerations around this. But I'm very pro the idea that actually almost every human role we have does have tedious bits that distract from adding real value. And you can sort of bring that to your own work. Where humans are doing things in your domain, which bits of that can be hived off, given to the computer so we can focus on the higher value work? So, can machines work? Yes, they can. You've got automation, generalizing, role replication. Can machines learn now? Well, we had a bit of stagnation in the progress of machine learning in the 80s. Weren't making much progress with this approach on the left of teaching the thing to follow instructions. And we had a bit of a breakthrough with this idea of novel AI, where we started to look at nature and think, nature actually adapts to the world and learns its own rules rather than being told all the rules up front. And in particular, people started looking at the brain and this idea that it learns from data, not rules, to recognize patterns. And recognize patterns is the key part of this phrase, because once you can take raw data and start to understand the higher level ideas in that, those are the building blocks of actual, I dare say this is a controversial statement, but of actual intelligence. So you're starting from raw data and starting to build up an understanding of what's going on in that data. Now, just a bit of history for fun. We have Jan LeCun, 1993, the first convolutional neural network. This computer can look at the raw data on the screen with just the digits. It's just black and white pixels. That's all it can see. And it's able to pull out these higher level ideas of the digits that you're seeing. It's a very basic example. And what we're getting here, this is stolen from 3 Blue, 1 Brown. Looking at these raw digits on the left, starting to build up an idea that that 9 is composed of a circle on top and a line down the side. And if you see that again, that's another 9. And the 8 is the circle on top and the circle below. So how can we bring this to your own practice? Where do users need to recognize patterns in their process? I'll give you a bunch of examples. Buying something online, on your phone, let's say, have to put in your credit card. That's a tedious process. People are dropping off. You can scan the credit card now and immediately get that in. People continue the process. Uber, scanning users' IDs, checking that it's a valid ID, and making sure that it's got the information required. Where do your team internally need to recognize patterns? So if people are putting in user-generated content, they're going to be putting in things that probably they shouldn't be. And I can't show any of those on the screen. But to give you an idea of what people will be uploading, this very popular website from a few years ago, hot dogs or legs, where you get to decide which are the hot dogs. Any volunteers? Which one of these are the hot dogs? It's obviously top right. The controversial one is, are the bottom left hot dogs or legs? I can confirm they are legs. So from machine starting to learn, you have this idea of pattern recognition, and you can just look at steps where users are recognizing patterns and be able to replace that with an AI. Other idea from the 90s is going to be really relevant as we start to understand the technologies coming on slightly later. Can machines predict? This is machines starting to come into, dare I say, adversarial relationships with people, or acting in strategic ways, crunching through very complex situations. This was enabled by this concept of big data. We suddenly had the hardware able to process massive data sets. And so even without necessarily having the maths around the modern AI, we started to be able to do incredibly complex things. A landmark moment is IBM's Deep Blue beating Garry Kasparov, at the time the world's strongest chess player, in 1997. Fun fact about that story, they played 2 matches. Garry actually won the first one, IBM won the second one, and then IBM, having declared itself the victor, shut down the program forever. So how can you bring this down to earth? Because you don't all have big data available. There's these ideas of anticipation and suggestion. So where are users faced with choice? I think we all have that familiar feeling of struggling to choose something from the menu. 67% of adults do. Apparently 40% of Gen Z won't go out to a restaurant if they can't see the menu online beforehand. So where you have choice, can we anticipate what people are going to want to see? Can we start suggesting things and making that a smoother experience? Classic example, Netflix. I think we've all struggled finding stuff to watch on there. They found, this was a few years ago, up to 18 minutes per session just finding something to watch. That's like a whole episode of something. And obviously, as we know, they went through and built a recommendation algorithm. This is now done with ML, but equally could just been done with regular algorithms. So from big data, we're starting to understand anticipation and suggestion, make real contributions there. Moving forward to the 2000s, can machines understand? On the right, Google Lens, scanning a picture of this dog, identifying it as a Labradoodle. And this is what's called classification. So we have the maths around neural networks, recognizing basic patterns. We then were able to add on massive data sets thanks to the rise of better hardware. And this, plus some new maths, allowed the field of AI to progress towards this bigger idea of deep learning. This is where you're able to crunch massive volumes of data and then learn in vastly complex and unstructured environments. This unlocked a huge new range of problems that we could solve. So 2 particular technologies to learn. One is machines seeing an image. On the left, identifying an issue in a body, cancer detection. On the right, object identification. And I want to call out how incredible this is. The machine has never seen this person's body before. Every body is different. And it's not only been able to understand it, it's been able to spot that actually something's wrong. On the right, again, this complex moving image with all sorts of backgrounds sliding around, lots of pixels changing every second, is being able to pick out who is the person, who is the bicycle. The other technology is recurrent neural network, used in predictive text, also flood detection. 3,000 detectors up and down the UK measuring water levels. We can now anticipate when those rises in water levels are actually going to lead to a flood well in advance thanks to this. So for you, when do your users need to see things in the real world? And secondly, where's the next step dependent on the last? To date, we've only looked at data that is being used to make decisions, to be able to make recommendations. We're now going to move forward to an era where we're actually creating new things in the world. And this is sort of the birth of generative AI. In the 2010s, this just looks like mimicking existing data sets. And there's 2 technologies here, GANs and diffusion models. It's not important to know exactly how they work from a UX perspective. What they're usually doing is text to more text to image, text to video. What I think is useful here, though, is understanding the domains in which these can still be really, really useful tools. This website is called thispersondoesnotexist.com. And none of these people are real. In fact, we can have a go ourselves. So this one, which also has a long name, whichfaceisreal.com. We get to choose which person do we think is the real person. So hands up if you think it is the person on the left, the lady. Who thinks the real one is the person on the right? Bit of a split decision. Okay, I think it was still person on the left. Okay, crowd consensus was correct. Let's go again. Hands up left. Hands up right. Okay, definitely more votes for the right. You are correct. So it's not perfect, but you can see that in the first example, probably about 45% of the audience weren't 100% sure. Okay, so how can you actually use these technologies for your own products? First, I just want to give you like a really simple mental model of what's going on here. And this is simplified, but I think it is actually useful. So you have this collection of training data. It might be the user's data, might be your data. It's unorganized. What you can do is train a model which essentially organizes that data. So just for example, a whole bunch of books in different colors has been organized in this illustration on the right into books organized by color. And it's not just the books in the training data, it's kind of filled in every single possible gap between the entries in your training data. So now you have a model, like this bookshelf. You can then go to the bookshelf and pull out any given example you need at any point along that. So if you want an orange one, even if there's nothing in the training data, you can pull something out there. But to give us sort of a more interesting understanding of what's going on here, this training data doesn't have to be labeled as this is orange, this is green. You can put in simply unlabeled data, and it will start, the model will start to pull out what attributes are within that data. It can actually understand what's going on inside. And so then, even if you don't put an input in which is labeled such as orange book, you can give sliders that allow you to dial different settings, which might be color, but you haven't told it color. You can just dial along inside the model to be able to find different things and different attributes within that model. So once you've trained a model on a data set, you can start to pull out different attributes, even if you haven't labeled the data set. So I'll give you a practical example of this. Training data, a whole bunch of different photos, turns into an organized model where it starts to understand the attributes. And here, the axis you're kind of seeing left to right is a lady's face going from blonde to brunette, sorry. And another example, mimicking specific qualities. Here you've got on the left, pulling out age, someone very young, moving forward to very right, on the right, someone older. So how can you use this in your UX practice? Firstly, ask yourself, where would users want to create a mimic of a data set that we can get our hands on. And then the sort of follow-on question that falls out of that is how much control and guidance do users need? Do we want to let them run wild with it, put in prompts, or do we want to give them really controlled dialogues and buttons and things to press? And a really down-to-earth example of this, e-commerce site selling glasses allows you to put your face in and then select which show you how the glasses would look on your face before you purchase it. This was actually just a proof of concept, didn't make it into production, because I think training the data was too expensive. But it shows that you can actually bring these technologies to life. The other use case is transformation. So here, Hollywood de-aging Brad Pitt. Do users have assets that they want to transform from one attribute to another? So here in the 2010s, to summarize, machines can mimic existing data sets, and they can transform them. In the 2020s, we went from just mimicking to creating entirely new things that have never existed before. And the range of situations you can apply this to has been unbelievable. You've got, yes, text to image, but now text to code. You've got videos creating new video games, images going to 3D. Pretty much any data type you can put in, you can get out something completely different. So to give you a quick tour of how we got here, we had this technology around deep learning, which really understands the fundamental ideas in a data set. And then we've also had this technology around creating new data. And with some new maths, it's not the same maths, we've arrived at the transformer model, which can sequentially create content. So for example, you can put in a video, it understands what's going on, and then generate the next frame, and the frame after that, and you get an even longer video, or you build out an entire video together. Or you put in a whole body of text, and then you can generate one word at a time to build yourself an essay or some code. And a quick video, which I think I'll skip over for the sake of time. It's just these amazing demonstrations of Sora, which is an OpenAI model. What we're seeing is you're seeing the AI model has understood all of these deeper concepts within the training data. As I mentioned, you've got lighting. Can we skip to the next slide? I don't want to take up the whole day. So we have this health app, people putting in their data, and you're looking to solve the problem of motivation. An idea is, what if you can use that data to create a new asset? You can create a health success story at the end of the month, which brings them back to the app to sort of see what they've done and reward people with a bit of fun to remind themselves of the progress that's going on. I have no idea if this is a good idea, this kind of Spotify Wrapped for health, but it's the kind of thing you can do now that you can create brand new assets out of nothing. So I'll wrap up with a few final questions. Firstly, applying knowledge. Where do users have knowledge they can use to create new stuff? Where are they doing that already? Can you start to do that? And secondly, where do users want to create something new with minimal input? Or where can you create an asset that will help an existing process? So transformer models you can create, and you can apply knowledge to create. And so that gives us a high-level view of the last 70 years. Obviously, I can't cover every single use case, but I'm hoping that out of this talk, you've got a sort of broad view of where we've come from. I think we can wrap on this cute picture of the furry critter, hopefully not getting burnt. So to wrap up, we've seen how far these technologies have come. And I think while it's very easy for us just to grab ChatGPT's latest API, that's actually a very limited box of tools. And there's so many things that we can now do with the last 70 years worth of progress. With rules engines, you can be unbiased, explainable. With natural language, you have this connection. You have natural inputs and outputs. From robotics and automation, this idea of simplifying multi-step processes or even multi-function processes. Neural networks, pattern matching, predictive algorithms, solving overwhelming choice, deep learning, seeing, and also able to predict sequences. The GANs and diffusion models we showed with the faces, those mimicking or transforming data, and transformers able to create and apply knowledge. I've been Will Taylor from Workflow.Design. Thank you so much for watching, and enjoy the rest of the day.